All right, number 7. We briefly talked about this in notes yesterday, but really didn't get to do an example. Um, we talked about multiplying by the conjugate when we have square roots like this. So no more one-sided limits for these last few problems, just evaluating the limits using different techniques. And you should get a sheet that says techniques for evaluating limits, so it has a bunch of different possibilities. So that should help you out. For this, we're multiplying by the conjugate. Remember, always first, see if we can substitute in. But obviously we're going to get 0 in the denominator, so that's not going to work. Also, when there are square roots, we don't want to just substitute in because sometimes it approaches it from one side, but on the other side the domain's does not exist, so the limit doesn't exist. But here we're going to multiply by the conjugate on the top and the bottom. When we do that, all sorts of good stuff happens on top. Right? This is like the difference of two squares. Like if you had x squared minus 9, you can factor that to x minus 3 times x plus 3. But whenever you have that, something minus something times the same thing plus that same thing, things are going to cancel out. It's going to be like the difference of two squares. So when we multiply this with this, we just get x plus 6. Right? It's squaring it, multiplying it with itself. Then we're going to get these middle terms, square root of x plus 6 times square root of 6, and then negative square root of 6 times this. So those cancel each other out because one's positive, one's negative. And if we take the negative square root of 6 times positive square root of 6, we're just going to get negative 6. Bottom, we're not going to multiply out or anything. We're just going to leave it how it is, and we're trying to cancel some things out. Well, on top, the 6's cancel out. 6 minus 6. We got the limit as x approaches 0 of x over x times square root of x plus 6 plus square root of x. Now the x's cancel out. And that was our whole problem to begin with. There was an x in the denominator, and we couldn't use direct substitution. But now, we've gotten rid of that, and that's the whole goal. So that's gone. There's still an x in here, but we can plug 0 in. It doesn't make the denominator 0. We get 1 over square root of 6 plus square root of 6. Well, if we add those, we get 2 square root of 6. And being the mathematical geek that I am, we can rationalize this, no square roots in the denominator, multiply top and bottom by square root of 6. We get square root of 6 over 2 times, when we multiply these, we get 6. So 2 times 6, we got 12.